Hello and welcome to today's webinar, which is on selecting the ideal wireless technology for sensor-to-cloud application development. My name is Jeremy Cowan and I'm Editorial Director and Co-Founder of IoT Now, and it's my very great pleasure to be your moderator today. Thank you everyone for joining us wherever you are around the world. We've got a very topical discussion for you, brought to you with Telit, plus an overview from Beecham Research. So the first thing to do is to welcome our speakers, and in order of appearance, they are Robin Duke-Woolley, founder and CEO of Beecham Research. Welcome back, Robin.
Great to be here, Jeremy.
And then I'd like to introduce Florian Herrmann, who is EMEA Director of Business Development for Short Range at Telit.
Hi, Jeremy. Very happy to be here. Thank you.
And I'm also delighted to say we'll hear from Sharat Jose, who is Head of Telit's Product Management for Wi-Fi. A warm welcome to you too, Sharat.
Thank you, Jeremy. Nice to be here, and thank you for hosting the event.
It's a pleasure. Now, don't forget, this webinar is being recorded, and from tomorrow you can access the audio and slides via our website at iot-now.com. We always want to know what you think, so we will, as we often do, have two polls, the first of which comes in a moment. And at the end, there is, of course, a chance to feature our speakers. So you can begin sending me your questions right now, and I will put them to our panel at the end. All you have to do is just click on the questions button and type yours into the window. Any that we don't get to today will inevitably be answered offline by our speakers. And finally, if you're having any technical issues with audio or slides, you can also use the question window to get advice from our tech support team. Today's webinar is going to cover wireless technologies that can scale easily, onboard data efficiently, use low power, and leverage unlicensed spectrum. But before we get into that, let's go to poll 1. Now, please remember that your replies are anonymous, so just click on one answer and then we'll have the chance to see the results immediately afterwards. And the poll question that we want to ask is, at what stage of wireless standard selection are you? Are you researching standards for applicability to your project? Have you selected a standard and are now researching vendors? Are you evaluating vendors and products? Do you have a short list of products to select from? Or fifth, are you not engaged in a selection process? So at what stage of wireless standard selection are you now? Researching standards, your standard is selected, number 2. Number 3, evaluating vendors. Number 4, you have a short list of products. Or number 5, you're not engaged in a selection process. Let's move forward and see what answers we've got. I always find this interesting. 33%, a third exactly, are not engaged in the selection process at the moment. But second highest answer was number 1, and that was researching standards for applicability to your project. Somewhere behind that at 16-17% is evaluating vendors, and very similar figures for having selected a standard and for those who have a short list of products. Florian, is that in line with your expectations?
Actually, we are in a situation right now because of all the IoT hype going on for a year that is very similar to what we see here. There's quite a few folks that are a bit further down the road that have already decided which would be the best one, but there's still a lot of people looking for advice on or information on what standard would be suitable for their kind of application.
Yeah. Shiraz, did you see any surprises in these answers?
Not really. I mean, what it really interested more was that, the evaluating vendors and products is like 16.5%, which is pretty interesting.
Just lost the end of that, but I think it didn't seem to offer too many surprises to you. So it's now time to move on to the first of our presenters, and that is Robin Duke-Woolley. Robin, the floor is yours.
Okay, thanks, Jeremy. Yes, so I'm just going to give a few minutes really to set the scene. Most of the discussion, I think, will be not technically based, technology based. So I would like to start from the other end. Many of you will have seen this slide before, which is the way that we segment the market for IoT and M2M as was. And this shows really it's an applications base, and it's a base around connected devices. So 9 key sectors that we think are important for this marketplace. But of course, that gives an overall view for all connectivity types. It's just intended to be indicative of the wide range of applications that there are out there. And then there are many within each of the individual vertical sectors. So the point here, I think, and this will be strengthened by the discussion today, all connectivity types have a part to play in IoT. They're all there are some competitive, but there are a lot that are complementary. So we have cellular, which we're not going to be talking about today. We have Wi-Fi, which we are, Bluetooth and Zigbee, which again we're going to be talking about today. Fixed broadband, we're not. Wireless broadband, we're not. Satellite, we're not. A wide area, maybe a bit, and then many others. But the point is that there are new applications are enabled when new types of connectivity come onto the market. And I'd just like to highlight that situation with low power wide area. So we've drawn this particular chart just to show, like the circle at the top is the sector chart that I show, and then lifting the bonnet, if you like, looking underneath the lower one is new application areas that are enabled through the low power wide area technologies. And there are other below the bonnet application areas for satellite, for Wi-Fi, for Bluetooth and so forth. So it's just worth bearing in mind that each of the technologies represents a range of applications that become available, and then of course you need to choose which is the most appropriate technology for a particular application. On the right-hand side here, we have a number of attributes for low power wide areas, so latency, battery length, and so forth, which are important characteristics, important attributes to take into account in deciding which technology to use for a particular application. So there's then a question of whether you are selecting a technology for an application or whether the application selects the technology. That's probably a question that we'll get to later. So that's by way of introduction. I'm now going to hand over to Florian at Telit, who's now going to take us through the first of these technologies. And over to you, Florian.
Thank you, Robin. So today we're going to look at what we call non-cellular technologies in Telit. These are made up of short-range technologies, but also technologies like LoRa and Sigfox, which are more comparable to cellular solutions actually. For all technologies, we usually build a deep know-how in Telit. We develop our own protocol stacks, we have our own modules, so we have the entire technology in our hand and are able to adapt quite quickly and easily to market and or project requirements. Telit is not only a module vendor, though. In all the IoT space, we offer connectivity services and are able to offer cloud solutions, including device management as well. Today, we will mainly focus on the short-range technologies, though. So each technology that is mentioned here is actually quite complex and can easily fill an entire webinar on its own. So we will only have a high-level view on these. As Robin out, IoT is all about connecting things to the cloud. Everybody wants to use the big data to analyze and optimize processes and generate new business opportunities. Telit's background is in M2M communication, so we kind of have always done IoT. It's just a different name for essentially the same business. Of course, there's a lot of new opportunities as well, and it's much more complex today than it was 5 or 10 years ago. And there's a much higher integration level. So today we look at integrating cloud clients in the modules already, embedding different technologies on one module. So everything gets smaller and more embedded. In the end, each project, each company has different needs they need to take into consideration when going for technology. Robin also pointed this out. The consideration can actually be grouped in 3 main categories. We have technical, we have commercial, and we have ecosystem-related points, whereas the ecosystem is influencing both the technical as well as the commercial points. So the main points that we see actually across all verticals is the ones that we listed here. The cost, the coverage of technology, the data throughput. The interoperability is getting more and more important, especially in verticals like smart home. Power consumption is important, scalability. Security is, of course, a very, very important case. And then for each use case, there are often very specific requirements in addition as well. Now, we will just briefly compare LoRa and Sigfox, as these are not really short-range technologies, but more like cellular technologies. They were both introduced at a point when neither narrowband IoT nor Cat-M1 were actually available, but there was a window in the market to gain some shares in the IoT area. So nowadays, both narrowband IoT and Cat-M1 are available, and the rollout is picking up quite fast. They still have their niche applications. So Sigfox is targeting very low cost, very low end devices. Just recently announced that they are able to do a solution at 20-cent cost. So this is addressing kind of disposables. Their network supporting millions of devices, but have a very low message limit. So in general, they build their own network and manage it, which also imposes some kind of risk, of course, because Sigfox, being the service provider, is a potential single point of failure. LoRa is a little bit different. It's much more flexible. It's allowing for bidirectional data transfer, and it's actually picked up by some telcos on a worldwide scale to build up public networks. But I think the main driving point for LoRa is actually the option to use it as for private networks as well. You build your own gateways, you have your own server, you have your own devices, which means more upfront cost, of course, but a lot less operating cost. It's especially interesting for smaller networks in specific areas. According to the IoT market verticals, a combination of long and short range technologies is of course needed in the IoT. We just talked a little bit about the longer range. And so looking at the short range technologies, there are some key features all of them share to some degree. Devices are often battery driven and get smaller and smaller. So if you look at the verticals like Industry 4.0, there's new equipment and systems will deploy hundreds of sensors to collect data. It's the same actually which is going to happen in the smart home area. So looking at the main technologies from a high level, we currently see this picture. Each technology has of course its own specific use cases and some are overlapping with others. Specifically Bluetooth, starting with the introduction of Bluetooth Low Energy, has given Zigbee a run for its money. Today, I would say Zigbee has no real advantages versus Bluetooth Low Energy, especially since the introduction of Bluetooth 5 and the long-range feature. Instead, Zigbee still has to fight a little bit with the not so good standardization, which often led to implementations adding proprietary extensions, which in return led to not interoperable solutions. Then, of course, we have the sub-gigahertz, which will always have its place due to the fact that it has the best range of all these technologies. And it comes with its own problem. Being proprietary means it's always use case, always project specific. So there's a lot of upfront cost involved here. The devices need bigger antennas. So you have different frequencies all around the world. So there are some limitations that are quite difficult to overcome in some projects. Of course, these are not all the technologies. You have Z-Wave, for example, which is just another proprietary technology, although quite successful in its vertical. But in the end, pictures can also change depending on how you actually use the technology. So, for example, if you use Wi-Fi BGN versus AC versus low power, you have a completely different setup regarding range, regarding power consumption, and regarding throughput. It's quite similar if you use Bluetooth BR/EDR, or if you use Bluetooth Low Energy. You also have a different outcome in your project. You will still need to understand what are the differences and what is the best solution for you. But out of all the mentioned technologies here, there are actually only two that are, let's say, well standardized on a worldwide scale and also have a huge ecosystem that you can essentially find anywhere. And these are actually Wi-Fi and Bluetooth. So in the following, I would like to go a little bit deeper into some of the things that Bluetooth brings to the table and you have to take into consideration when integrating Bluetooth. And Sharath will do the same for the Wi-Fi. So just the very basics. We have classic Bluetooth, which today essentially is only used for audio, you could say. We have the dual mode, which today is integrated in every smartphone, in every tablet, in most PCs. It gets integrated in gateways more and more, in TVs. So then we have Bluetooth Low Energy, which is actually the most interesting one. It's a kind of a cost down and simplified version of Bluetooth. And this one was actually specifically designed for low power IoT applications. So why is it so good? I mean, Bluetooth is low energy in particular is highly configurable. You can set advertising and connection intervals to a few milliseconds or seconds. Either it is very fast or it is very power efficient. Any middle ground can essentially be used, affecting throughput and power consumption. So it can be optimally tuned for your application. It offers state-of-the-art security, even FIPS compliance, which is important for any payment applications. And with the mesh that was introduced last year, it also offers a lot of different network architectures, point to multi-point, point to point, and now mesh as well. How is Bluetooth integrated? And this is actually true not only for Bluetooth, but for most of the other technologies as well, although HCI is a little bit of a special case for Bluetooth. But in general, you could say you have complete embedded modules, like the ones that we sell, for example, which come with everything embedded. You have the Bluetooth stack, you have a microcontroller, you have the RF part, essentially everything. Then you have the option to take an HCI module, which is kind of only the RF part of a Bluetooth design, and everything else is on the host system. Or you could go for a chip integration, which means that you just take every part and put it on your own board yourself. So just briefly looking at the advantages of embedded modules, it's obviously the fastest and simplest way to integrate a technology as a very low integration cost. There's no know-how required for this to integrate this, and usually you get complete products which are qualified and certified, and it also has the least impact on the host system. This is of course mostly or most often, let's say it this way, interesting if you have an existing system you really don't want to touch or you don't want to change a lot. The disadvantage here is, of course, the higher BOM cost in comparison because you buy a complete product. HCI modules are a lot cheaper because they are just the RF part, so you still have on your own, you have to figure out how to integrate the Bluetooth software stack on your host controller, which leads to a longer development time, but mainly on the software side. In this case, the product is RF certified, but you will still need to go for Bluetooth qualification. And the last but not least is the highest integration level is the chipset integration. It has a very low BOM cost, of course, and it has a very low footprint, although today there are very, very small complete modules available as well. So this one means you need to know everything about RF design, you need to know everything about Bluetooth, because essentially you're going to do everything on your own and doing all the certifications as well. So this is usually something that is really only worth if you have a really high volume product. So what we sometimes see is that customers, they start out with an embedded module to get to know the technology, to also see the market reaction on the product. And then later, when it really takes off, they do a redesign for cost optimization. And often we discuss chipset integration in that case. Now, the ecosystem is, of course, huge. I just put a list here for your reference of all the operating systems since when Bluetooth Low Energy is supported, essentially since for years in all the major devices. There is, for everyone that does not know it, in the Bluetooth SIG maintains a website and a list with all the registered Bluetooth devices where you can check on all the functionality that is supported by a given device. So if you're not sure, but you want to be able to communicate with a given phone, for example, you could do that. Important is, if you look at Bluetooth, to clarify some very basic parameters that affect your integration greatly. What is your remote side? Is it under your control, or is it a third-party device? Is it another module? Is it a smartphone? Is it a PC? This affects a lot what you have to do on your side. Are standard profiles supported? Do you need to support those profiles? Do you need to support a specific operation mode? Like if you want to support an old infrastructure, you need to be able to support Bluetooth Classic also. It actually also affects the possible throughput that you can achieve, because these devices like smartphones and PCs, they usually impose connection settings, which means you are not guaranteed connection speed, and this needs to be tested. So is there standard profiles available? Are these sufficient? Because if not, then you have to develop your own service or profile, or you can use something like Terminal I/O, what we provide, which is essentially a transparent data channel, which we provide for iOS, for Android, on all of our modules. So there's a whole ecosystem we cover and make Bluetooth integration quite easy. Then what about security? Does your device have an UI? This is important for the pairing. Is, let's say, just works pairing sufficient, or do you require man-in-the-middle protection? If your UI does not have a display or a keypad, you cannot enter or read any pins. So you have to think about how to solve this. An option would be, for example, to use another technology like NFC to do the pairing. Then you have to decide between latency and power budget, or between range and throughput. You can either have higher range or better throughput for Bluetooth Low Energy, but not both at the same time on the same Bluetooth link. I will talk about this later when I talk about Bluetooth 5 features a bit more. Then, of course, the device itself, the housing, the antenna placement, everything affects the design. So looking at the Bluetooth 5 features in particular, because they open up a whole lot of new applications for Bluetooth, and actually they enabled Bluetooth to be on the same level as Zigbee in a lot of applications. We have, on the one hand, the increased bandwidth, increasing the 1 megabit to 2 megabit PHY. in real world, if you look at our embedded modules, we can achieve from module to module about 500 kilobits per second currently with a 1 megabit PHY. Just for your information, under iOS, this is halved. It's not because we perform worse, but it's because iOS does not allow us to go faster in a way by imposing its own settings. So we expect this to double for sure. We have the increased range under Bluetooth 5, which promises up to 4 times the range. In reality, it will probably roughly be double. It uses a so-called LE-coded PHY, and what it does, it actually reduces the data rate down to 125 kilobits per second and uses something they call forward error correction, effectively increasing the sensitivity, so increasing the link budget. So they don't increase the output power to keep the energy consumption low, but improve the sensitivity. Important here is that since the data rate is reduced for the long range, it cannot do high throughput. So again, you have to understand all these things for your application and be able to adjust it accordingly. Then there are additional, like broadcasting channel improvements, which is mainly for beacons. Beacons today, they are not just stupid Bluetooth beacons. Most of them come with sensors, so they have more data they want to broadcast. And this one actually enables them to also use channels which are not advertising channels, so these don't get blocked if you have more data you want to broadcast. And then there's also the slottability mask improving the coexistence of technologies in the 2.4 gigahertz band, which a lot of technologies use. The question is, or it's important to see, all the Bluetooth features I just mentioned, they are optional. And they need to be supported on both sides. If you look at a device and someone claims it's Bluetooth 5, you need to make sure that it actually supports the feature you need, because just a Bluetooth 5 certification does say nothing. For example, I did check on the mobile phones on the Samsung S8 series and the Apple iPhone 8 and 10 on the Bluetooth SIG webpage. They do support the 2 megabit PHY for Bluetooth 5, but they do not support the LE-coded PHY. So that means you cannot communicate on the long range with these devices, although you could use the higher throughput. Now, looking at cloud connectivity, Bluetooth offers 3 standardized ways for sensor to cloud. The first one is the use of IPv6 over the Internet Protocol Support Profile, IPSP. This gives a kind of a continuous connection between sensor and cloud with equal capabilities. It has the advantage that there's no data conversion necessary. There's less complexity on the routers, and it can essentially be used with any cloud out there. Of course, it comes with a disadvantage. It comes at a cost because the sensor needs to be able to carry an IPv6 stack, which actually means that the sensor is not really that cheap and power efficient as it potentially could be. The second option is mainly about cloud to sensor connectivity. So it's the way that the cloud reaches out to the sensor to get some information. This one uses standardized RESTful APIs. So the advantage here is you can use real low power standard sensors. You can use a temperature sensor which runs a standard temperature profile. There's nothing specific here. You also have a standardized web interface by using the RESTful APIs. The disadvantage is, of course, the gateway needs to know how to handle the Bluetooth sensors. It needs to know the Bluetooth, and it also needs to have the RESTful API, so it's acting kind of in between. So this one is the disadvantage is also that the sensor by itself cannot inform the cloud, but it always starts with the cloud asking the sensor. The third option is using something that is called HTTP proxy service. This is also a standard service. In this case, the sensor asks the gateway to HTTP post information to a cloud. And this one is actually a very simple service There's no dedicated Bluetooth application required, neither on the gateway nor on the cloud, and there's also no permanent connection to the sensor required. The only disadvantage of this is, so if you have a very simple temperature sensor, for example, which is on your window, which has no other connection, or motion sensor, this could work, that just the sensor reaches out to the cloud when something changes. The disadvantage is there is no way to address the sensor from the cloud, since the sensor will be asleep all of the time except for something changes that he wants to have tell. Now, last but not least, I want to mention, of course, the mesh that was released last year, the mesh specification. The Bluetooth mesh requirements are, or the main requirements are actually, it needs to scale, it needs to be very robust. There shouldn't be a single point of failure. You want to be able to very easily reconfigure the mesh to add new devices, also to remove devices. You will have you need a high level of security. You need ideally a very low power consumption, and okay, the latency depends a lot on the exact use case. Now, the Bluetooth mesh itself was developed with the lighting application in mind, and as such, the mesh is kind of defines the transport layer of the mesh mainly, and then on top of that, there are, like in normal Bluetooth operations, there are kind of profiles which are available currently only for lighting applications. And the Bluetooth mesh comes in the form of a managed flooding mesh, so taking the advantages of the flooding mesh network, but trying to fight some of the disadvantages by having it managed. So, for example, you have the time to live message counter, which only allows 177 hops per message, or you can cache messages so you don't have duplicate messages. You have usually the routing nodes are not that power efficient, so you probably cannot run them on battery because they are supposed to be bulbs, they are supposed to have mains. But there are ways with so-called friend nodes and leaf nodes, so the edge nodes, they can go very low power, sleep most of the time, and the friend nodes can cache information for them. And in general, you can build groups where nodes can subscribe to. So it's very optimized for this particular use case, and there are more in the works right now. But this is something that is going to come in later this year probably. So this was a quick overview. I know it was a lot for how Bluetooth can be integrated in the IoT space, how it can achieve some cloud connectivity by using standardized ways, and what you need to be aware of when integrating the technology. So that's it for me for now. So I would like to hand over to Sharath to go on with the Wi-Fi.
Thank you, Florian. Thanks a lot for providing a great insight into the short range technologies. Okay, so today I will not get into the evolution of Wi-Fi here, since it's already emerged as an ubiquitous RF technology for the IoT markets, right? Now, rather, I would like to spend the remaining time to go through the pain points a design engineer face while selecting the right part. As said, it's very easy to get lost or misguided while making these decisions, since there are a lot of subtle factors to consider which decides the success of the product. Again, if you don't get it right, the product will suffer in the field, right, for obvious reasons. As I said earlier, the list is huge, but please make sure all these are vetted before nailing down the solution provider. So let's start with the Wi-Fi standard supported, like BGN versus ABGN versus ABGN AC, right? People believe it is very easy to make this decision and get carried away with the fact that 11AC provides high bandwidth. But at the same time, I mean, a designer should understand that, I mean, the coverage of AC is significantly less than a BGM. I mean, so by coverage, I mean the range. Also it's power hungry. So if your product is expected to operate in battery, it will drain out pretty quickly. So what I'm trying to say is that, I mean, if you need to make an informed decision, I mean, so basically, so you make an informed decision based on the product use case, right? Now, coming to the security, it's a very important aspect of any product, as we all agree, right? As the market of IoT is taking shape, there are millions of devices getting added up every day, and it is more important than ever before, correct? So every solution provider offers security like WPA2 personal, enterprise, etc. But what is more important is how are you achieving it? I mean, with the security aspects are handled by separate hardware engine. That means there is a separate dedicated crypto block in the module or the silicon, or achieved in software. I'm highlighting this because it makes a significant difference in terms of timing. For example, the security handshake time, the memory that needs to be reserved for it, the computational complexity, etc. Right? So it's the same for the subsequent things like the throughput, the power consumption, etc. Now, yeah. Anyway, coming on the power consumption, it's one of the very interesting topics because. As you know, unlike the other short-range technologies, the Wi-Fi provides a wireless connectivity for both low and high bandwidth applications. Now, this means that it supports various data rates, modulation techniques, extended range. And some of this makes the radio pretty complex, and that results in an increased power consumption. Now, so to make Wi-Fi viable for battery-operated low-power devices, various power-saving schemes have been implemented in both SoC and software, apart from the standard IEEE protocol, right? Which is governed by 802.11 protocol. Now, these system power-saving schemes are vendor-specific, but made sure it is interoperable with other devices in the network. So I do have a slide, on particularly on the low power. Let me just jump directly there. This slide gives a brief overview of the power saving capability of Telit GS2K modules. Now, the most advanced feature of GS2K family of modules is its capability of transitioning the system into ultra-low power modes, namely deep sleep, standby, hibernate, and hibernate. There's a graph on the left side which really shows, the current consumption versus the boot up time or the wake up time, right? Now, as you see, the system can really transition into like 440 microamps and wake up within 10 milliseconds. Similarly, the system can also be transitioned into like 6 microamps or even 260 nanoamps, which is unmatched in the industry, and wake up within like 25 milliseconds or 200 milliseconds. Correct? So now to give you a perspective of a real world use case, which demands the Wi-Fi device to check the data availability from the cloud server every second or every minute, the ultra low power offering from Telit approximately saves 97% of the power compared to a power saving scheme which is defined by the IEEE. So you can see in the right side there is a sensor to cloud use case defined, and you can see in the table there is a data interval of 1, 3, 5, and 10 minutes. That means like the temperature data is uploaded to the cloud every minute or every 3 minutes. And using a AA battery, you can see the GS2K Telit modules will be able to achieve approximately 3 years of battery life. Now, that's pretty significant. Now, let me just jump back. Right, let me just, skimming the hardware resources, let me just jump to the platform software features, right? Now, again, I do have a slide on this, so I'm sorry for jumping up and down. So, This particular slide gives you an overview of the Telit platform software capabilities, and I could definitely bet that is one of the feature-rich, one of the feature-rich offering in the industry. As you can see, it really ranges all the way from the Wi-Fi layer all the way to the IoT application. So you can see in the Wi-Fi do support station mode, soft AP mode, which is an access point mode. It supports enterprise security, personal security, Wi-Fi concurrent mode, which means that the device can operate in access point mode and station mode at the same time simultaneously. It supports Wi-Fi direct, row mode, and various other schemes. And now going to the IP layer, it do support IPv4 and v6. And moving up, it pretty much support everything on the TCP, the network stack, right? TCP/IP, DHCP server client, and things like that. Now, the important thing to really note here is the security. So you can see, it do support, HTTPS client, HTTPS server, secure boot, flash encryption. Pretty much everything which is available. Now,
Oh, we seem to have lost audio for Sharaf. I don't know if... Florian, are you able to hear Sharaf? Because I can't pick him up.
No, he seems to be gone.
I'm sorry, when I got disconnected in between.
Don't worry.
Am I audible now?
Important thing. Carry on, carry on, Sharaf.
I'm sorry for that. Okay, so I was talking about the platform software, right? So as you can see, it's a pretty much feature-rich stuff all the way from Wi-Fi to IoT applications. It do support off-the-shelf software modules for the cloud connectivity or the cloud connection manager. It do offers for the device-wise Telit Cloud, Amazon IoT, Microsoft Azure, and things like that. So what I'm trying to say is that it really offers a full-blown platform software which can be utilized, for developing the IoT applications. Now, going back to the selection considerations, look at the cloud connectivity, right? Now, it's pretty tricky. Here you need to make sure that the platform software provides all the building blocks for exchanging data with the cloud. For example, like HTTPS, MQTT, WebSockets, etc. Right? Now, it would be great if vendor provides off-the-shelf cloud connection managers, as I just talked about. Earlier in the previous slide. Providing off-the-shelf software modules for connecting to the device-wise cloud or the Amazon cloud or the most commonly used cloud platforms, right? Now, over the air firmware upgrade, correct? Now, it's pretty interesting. Again, I have captured a slide. just to bring right. So here, as you see that, the Telit modules do offer a digital signature verification enabled, firmware upgrade mechanism. That means that the device can be upgraded from the cloud or from the smartphone over a very secured, channel, which is encrypted. And the firmware integrity, is also made sure, and the genuineness. When I say genuineness, it needs to be made sure that there's no man-in-the-middle attack, there's nobody who has really tampered the firmware. So, this entire scheme is already in place and is offered as an off-the-shelf stuff. And so this entire scheme has been achieved using the digital signature verification, right? Now, just going back, to the same slide where we were, which talks about the other provisioning schemes. So as you know, the provisioning, or the industry sometimes call it as onboarding, which is another inevitable piece in the puzzle, right? So you don't need to really invest your time in reinventing the wheel. What the industry has already figured it out. So going to the next slide, I mean, you can see that the list is on and on, goes on and on. I mean, all the way from certifications, I mean, there are compliance, which are the Wi-Fi LNs, and there are radio certifications targeting each region, like FCC for North America, I mean, or USA, I mean, IC for Canada, RED for Europe. So it based on the region, right? So then there are antenna types. It could be external antenna. It could be an internal antenna. Maybe, again, it becomes complex because, I mean, whether you want to really provide, even for the external antenna, do you want to really have an UFL connector or an RF pad and things like that, correct? Now, I would really, I mean, make sure that if looking at the interoperability, right, I mean, which is one of the, I mean, maybe the fourth on the list, this is one of the very important aspect. I mean, because you should always look for an AP compatibility report you should always ask for an AP compatibility report from the vendor, because, I mean, there are hundreds of access points out there in the market, right? And you need to make sure that when the product is installed in a particular region in the world, I mean, it doesn't really run into issues, correct? So similarly, I mean, there are other considerations that needs to be made in terms of operating temperature, the dimension, the packaging type. It could be LCC, LGA, I mean, protection programming, in-field debugging, quality, and many more, right? Now, support, I mean, so, but not the last, but one of the most important things in that, I don't need to explain for sure, I mean, how important it is for the success of the product. Now, the IoT know-how can make a significant difference in all the phases of the product life cycle, all the way from evaluation, the design development, certification, production, and the post-production, right? The support can really play a significant role in the success of the product. Moving on, I think we have already covered the slide. I mean, when we really talked about the low-power Wi-Fi, this as well, I mean, on the platform side. Now, this slide, I mean, I just put it here particularly to give an overview of the various software models which is prevailing in the industry now, I mean, to just help you make the right decision, right? So you can see there are three different models which is there in the market today. One is typically called a transceiver IoT Wi-Fi, where the Wi-Fi module or a Wi-Fi silicon is associated or attached with a host MCU, which an example is a Linux, which is a very powerful MCU, which is running either Linux, Android, WinC, etc., and which hosts the networking services, the entire IoT application, the IP stack, and everything, right? So here in this case, I mean, the Wi-Fi module merely work as a transceiver. I mean, it just gives us a pipe for the transfer of data between the device and the cloud. Now, the second one is a hosted IoT Wi-Fi. I put it that way because there is a host MCU, which could be, I mean, like an 8-bit MCU, even an 8-bit MCU, but interface to the Wi-Fi module is over some of the standard interfaces like, I mean, SDIO or an SPI or a UART. And the prominent, I mean, interface, the software interface between the host MCU and the Wi-Fi module is over AT commands, right? The simple AT commands. Now, in this case, as you see in the presentation, I mean, the network services, the IP stack, the wireless LAN services, everything runs in the Wi-Fi module. So the host MCU is pretty much relieved of all the wireless LAN capabilities, and it just talks to the module over the simple AT interface. Now, the last one towards the right is the standalone IoT Wi-Fi, where there is no host MCU involved. The entire application, the IoT application, the networking services, IP stack, wireless LAN, everything resides inside the module or the silicon, right? It's a system on chip. Now, I mean, it's pretty interesting because, I mean, because here you can really avoid a host MCU completely, correct? So let me just jump into a slide which really provides an overview of what are the various application development kits that the Telit offers, I mean, particularly on the standalone IoT Wi-Fi, right, to really speed up, I mean, your development cycle and get into the production faster. Now, some of those application development kits are like, which has been captured here are like 720p video and audio streaming. So here you can see there is a video which is being streamed from the IoT device all the way to the cloud and to the smartphone in the hands of the customer. And it also do allow a full duplex, full duplex audio, in either sides. Correct. Similarly, we also do support a 1080p video solution, which is in the engineering phase at this point in time, and will be releasing faster. Again, you can see there is an Apple HomeKit, HomeKit support. One of the differentiation which I would really bring your attention is that really it supports iCloud connectivity, so you can really get rid of your Apple TV in homes. And then there are like smart home, which is primarily the smart plugs and the smart power strips. And as I mentioned earlier, we also do offer some of the AWS IoT starter kits, which enables you to really directly connect your application to the cloud. Now, with that, I will just take you through the Wi-Fi module offering, which the Telit offers. Now, as you can see in the bottom left, there are 3 different modules in the protection today: 2101 MIP, 2200 MIZ, and WE8667P. And all of these are BGN capable today. And if you look at 2101 MIP, it is particularly positioned for the low power, line powered market, whereas 2200, as we have seen, it is particularly for the battery operated low power devices. Now, towards the right, you can see that the modules which are in engineering phase at this point in time expected to be released in the later half of this year. And we are coming up with dual band ABGN modules. That means like we'll be supporting 2.4 gig and 5 gig ABGN, and it is also going to be a combo module, that is Wi-Fi plus BLE5, correct? And on the top, you can see that we are also coming up with an ABGN AC part, which is again a dual band 2.4 gig and 5 gig with 11 AC capabilities with a BT 4.2. So this is the various module offering that we have at this point in time on the Wi-Fi. So to conclude, I would really take you to this slide where I would really say that Telit really offers a complete IoT solution, which do have a comprehensive module roadmap with single band, dual band, BLE combos and things like that. It also provides an IoT focused reference designs, excellent support, quality, and this global certification to really take out the pain of the customers. Looks like we are running short of the time, so yep, that's all from my side. Thank you. Over to you, Jeremy.
Thank you, Sharath. That's excellent. Plenty of detail for us to get our teeth into. Without further ado, let's go to the questions from our audience. The first one that we've received says, you recently announced support to LUA scripting language for your BT modules. How much resources are available for the script? Florian, would you be able to take that one for us?
Yeah, sure. So the LoRa scripting language is actually quite commonly used in low-end devices, and on our BlueMod S42 module, there is 20K of RAM and 32K of flash available for running the LoRa script. So that is plenty of size for a script.
And this is probably a question for you, Sharath. For your low-power Wi-Fi products, how can you mass provision a large group of devices at the same time onto the AP?
Right. So we do support an Android and iOS application. Which really there is a proprietary way of doing this, and it is already supported and out there in the iOS market and Android market. So it really connects to the devices over secure channels and provision every single device one at a time, and which is seamless to the user. So there is already a scheme available from Telit to really mass provision the devices in the market.
Yeah.
We can provide those informations offline if it is more details are really needed on this.
Yeah, I think that's a really good idea. That would probably be helpful. We've got a questioner in India who asks how BLE5 interfaces with the cloud. What's the roadmap for that? Florian, that's probably one for you.
Yeah, so actually I talked about the three standardized ways how this can be done in my slides. And there's actually another question going in the same direction that I saw, where someone was asking about the article that Mozilla is working on an open source for integrating Bluetooth connectivity. So there's actually a fourth way how this actually can be done. This is something that is called Bluetooth Web, and it's developed by Google mainly, I think. It's not finalized yet, and it's actually kind of enables the browser like Chrome and also Mozilla to enable as a gateway between the internet and Bluetooth peripherals that are in the same area.
I see. While I've got you, Florian, let's go with the next questioner who asks, when using an embedded device, do I also need to pay a fee to the Bluetooth Alliance in order to sell my equipment if it includes BLE embedded devices?
Sadly, yes. So this was changed a few years ago. We have to pay the qualification for our product, but in the qualification process, there's two ways. One is running through entire qualification, which includes a lot of testing and verification. This is what we do. And then there is, when you use our modules, you still have to do a listing. And this listing includes paying a fee to the Bluetooth SIG just for the listing itself, just for being able to use the Bluetooth mark and this kind of stuff. So yes, you have to pay.
Okay, well that's pretty clear. And a questioner here asks, with BLE Mesh, what is the scaling capability for large networks? Probably I'll stay with you, shall I, Florian?
Yeah, so the spec does allow for, I think, 32,000 nodes to be provisioned according to the specification. But in real world, I mean, the specification was done last year. So what we have seen so far is networks reaching about 1,000 nodes effectively right now. So it will take some more time until this will scale in a bigger rate, I think.
I'm going to come to you now, if I may, Sharath. The questioner here asks, which technology would you suggest for indoor tracking of devices, and how accurate can we get it? And he puts brackets Wi-Fi or BLE or any other technology.
I mean, it could. Yeah, you want to answer that, Florian?
I can answer it for BLE. That's somehow used for this kind of application. Using triangulation. There's actually a lot of things upcoming regarding location-based services in the upcoming Bluetooth solutions. So right now, it's a little bit wonky using LE because the only real means you have is based on the RSSI value, which is not that reliable if you are in very noisy environments. So LE it's possible to do it, but it requires quite some effort and know-how on the triangulation part and trial and error, I guess. And also on the Wi-Fi, I've seen also Wi-Fi tracking solutions. Sharath, perhaps you can say more about that.
So it's somewhat the similar situation in Wi-Fi as well, because it's primarily revolving around the same triangulation schemes, depend on that. Now, it's especially since, I mean, it's an indoor tracking. I mean, you need to really have an ecosystem for supporting it, and that means that you need to heavily invest on the infrastructure, what is really needed. So in terms of technology, I mean, it really depends on the triangulation and how long the race traveled and came back to the device. So it's in terms of accuracy, I don't have a good answer. But I can definitely tell you that, and the Wi-Fi, I mean, you need to really heavily invest on the infrastructure, I mean, for really getting to such a solution.
Yeah. Well, that's pretty fair. And obviously, if there is more detail that you want to share with our questioners, I'm sure you'll be able to do that offline after the event. Sadly, I'm afraid that is all that we have time for. So thank you, everyone. As you know, the aim of this webinar has been to help you select the ideal wireless technology for sensor-to-cloud application development. And as you've heard, we talked through the latest developments in Bluetooth and Wi-Fi and touched on other wireless standards so that you can see how you can create your business and product breakthroughs. I'm afraid that is all we have time for. So please don't forget to bookmark our website. That's at iot-now.com. And you'll find the latest news there. You'll find awards, videos, blogs, events, and interviews. And from tomorrow, you can stream this webinar from that site. It just remains for me to say a huge thank you to our speakers. So they are Robin Duke-Woolley from Beecham Research. Thank you, Robin.
Thanks very much, Jeremy. Great to be here.
And thank you, too, to Florian Herrmann from Telit. Good to have you here, Florian.
Thank you, Jeremy. Thanks for hosting this.
It's been great. And finally, from Telit, also, Sharath Jose. Many thanks for your time, Sharath.
Jeremy, it's my pleasure.
Well, it's most of all, ladies and gentlemen, thank you for joining us around the world. Keep safe, and we really do appreciate the time you've spent with us. From everyone here at IoT Now, enjoy the rest of your day. Bye for now.